In this video, we want to use logarithms to compute the derivative of this first problem, number 1 here. And for number 2, we want to use logarithmic differentiation to find the derivative. So for number 1, if we take the derivative as is, using just your regular formula for the derivative of natural log, we would put this expression in the denominator, and then we would compute the derivative of the expression in the numerator, and then simplify. Now, if we use properties of logs, which is what we're going to do here, there's a property that tells us if we have the natural log or the log, doesn't have to be natural log, just any log of a fraction, that's going to be the same thing as the natural log, in this case, of the numerator minus the natural log of the denominator. So again, simplifying this using properties of logs, I take the log of the numerator minus the log of the denominator. And when you have a log of a product, you can write that as a sum of the logs. So instead of the log of e to the x square root of x, I can write that as a sum, ln of e to the x plus ln of the square root of x. Now I haven't taken the derivative yet. I'm just simplifying here. For the second one, I have minus the natural log, I have this to the 6th power here. Property of logs allows me to bring this exponent as a coefficient out to the front. So this will be 6 ln of x plus 1. Then I keep going here again. Haven't taken a derivative yet. Now this one I can simplify. This is natural log, and I have e to the x. So the natural log of e to the x, because this is basically, that just becomes an x. And then this is the square root of x, or you can look at that as x to the 1/2. So just like in this step here, I can bring that exponent to the front as a coefficient, 1/2. So this becomes 1/2 natural log of x. And I just rewrite the next one, minus 6 ln of x plus 1. Now I'm going to take the derivative expression by expression. So this will be y prime, that's the derivative dy over dx. Derivative of x with respect to x is 1. And then here I have a constant, so derivative of ln of x is 1 over x. So this will be plus, again, derivative of ln of x is 1 over x. So this becomes 1/2 times the 1 over x. I just put it this way. Then I got the minus 6 here. And again, the derivative of ln of x plus 1 will be 1 over x plus 1. In other words, this comes to the denominator, and then you take the derivative of x plus 1, which is 1, and you put it up here. So that's pretty much it. I'll just rewrite this. Instead of leaving this 6 here, I put the 6 over here. So the answer to this one is 1 plus 1 over 2x minus 6 over x plus 1. Now, if they tell you to combine this, find your LCD, just about doing the algebra, and combine it, I'm going to leave it in this form. Say this is the derivative. Let me clear this so I have more room. Now for the second one, I want to take the derivative, dy over dx. So I could group these together, these two, or these two, doesn't matter, and write it as two functions, two powers, and I can use the product rule. Sometimes it gets a little bit messy when you do the product rule this way. So what we're going to do is we're going to take the natural log of both sides here. So I'm taking the natural log of both sides. Again, I'm going to use properties of logs, but this one's a little bit different because I'm going to take the derivative once I take the natural log. The first one I already had the natural log. That's part of the problem. Take natural log of both sides. I got x plus 1 to the 7th, x plus 2 to the 8th, and x plus 3 to the 9th. And you'll see this method works a lot easier. Okay, so then I got natural log. Now I'm going to use properties of log. So again, anytime you have the log of a product, you can write it as the sum of logs. So this one here, then I can bring it up into the natural log of x plus 1 to the 7th plus the natural log of x plus 2 to the 8th plus the natural log of x plus 3 to the 9th. And then the next property allows me to bring the exponent, as I did earlier, as a coefficient. So just to save some steps here, then again, write it as a sum, and then the 7 comes out for this one, and for the second log, the 8 comes out, and then the 9 comes out. So it'll look like this: 7 natural log of x plus 1 plus 8 natural log of x plus 2 plus 9 natural log of x plus 3. So again, took the natural log of both sides, and then on the right side, I'm using the property that allows you to break it down when you have the natural log of a product, just the sum of the logs, and also if you have an exponent. So this one, it would be like this. So the step I skip would be a 7 would be here, an 8 would be here, and a 9 would be there. And then the next step brings it to the front, like this. 8 here comes over here, the 9 here comes over here. Now we're ready to take the derivative. So on the left side, I have ln of y. So I'm going to take the derivative of that. That would be 1 over y. And then we use the chain rule. Y is a function of x. So then we multiply this by the derivative of y. That's y prime, or dy over dx here. And then all I do is take the derivative term by term. And by term, actually, I mean this expression here, this expression here, this expression here. So since 7 is a constant here, 8 and 9 are constants, take the derivative ln of x plus 1 will give me the x plus 1 goes to the numerator or denominator. And then I take the derivative of the expression here. That's the chain rule. I get 1, and then 1 times the 7, you get this. And then it's plus. The same thing, derivative of this brings the x plus 2 to the bottom. The derivative of x plus 2 is 1, that goes to the top. So this would be 8 over x plus 2. Same thing for the other one. It would be 9 constant, so derivative of this again will be x plus 3 in the denominator. Derivative of x plus 3 is 1. 1 times 9 is 9, so I get 9 over x plus 3. I want to solve for y prime, so I'm solving for actually the y prime here. So what I'm going to do is multiply both sides by y. So multiply both sides by y. So let's multiply this side, parentheses here, by y. Then multiply this by y. Those cancel out then. I just get y prime on the left side. Just so I don't have to do that much here. Let me just cancel those out here. So I get y prime, and I can write it as dy over dx. And I got this over here. This is your answer. And this is, now you could leave it like this. You could leave it like this. And then down here you can say where y is equal to, and then you can just write this expression here. I'll put it right here. X plus 1, 7th, times x plus 2 to the 8th, times x plus 3 to the 9th. And depending on what they ask you for, you could find the LCD and write this as one expression. I wouldn't require that in my classes, but somebody else might. And instead of putting this y here, the way I did it there, and then said y, where y is equal to this, you can just write this whole thing here. Instead of this y here, put parentheses right here, and put x plus 1 to the 7th, times x plus 2 to the 8th, times x plus 3 to the 9th. Either way you want to do it. Thanks for watching. We'll see you next time.